All right, guys, we're going to do a little intro video on graphing when we have a variable in the denominator. We have the x in the denominator. We're going to begin with this simple basic equation, y equals 1 over x. So how do we graph this? So let's graph it like we would any other function, like if it were a function machine where you plug in an input and you get out an output. You plug in an x value, you get out a y value with an xy table. So let's begin by plugging in something pretty simple. How about like -4? So when I plug in a -4 right here, well, I will have a 1 over -4, which means that my output will be -1/4. Okay, that's pretty easy. Let's plug in a -2. If we plug in a -2 right in here, well, we'll get an output of 1 over -2, which is really just -half. And what if we plug in a -1? If we plug in a -1 right here, it'll be 1 over -1, which is -1. Now, I did pick these numbers on purpose. Like, we could go further negative, like we could say -10. However, that'd be -1/10, and that's even closer to 0, right? So I picked these numbers on purpose because we all understand -1/2. We all understand -1/4. And if we did plug in a -10, we do know what -1/10 is. It's even closer and closer to 0, which reminds us of our asymptotes. And we will have asymptotes right here on this graph. Now, look at the inputs. I went from -4, -2, -1. Let's plug in a 0. But if we plug in a 0, that will mess this up because 1 divided by 0 is undefined. If you did that on a calculator, it would say error. So 0 doesn't work. How about this? Let's graph what we have so far. Let's go to the coordinate -4, -1/4. -1/4 is right here, not even halfway down. Let's go to -2, -half, -2, and -halfway down is right here. So let's put a dot right there. And then we go to -1, -1, -1, -1. Put a dot right there. So as you can see, we have this weird curve so far. Now, again, what if I were to plug in a -10, which would be way out here? Then we would get a -10 down here, which would be a -1/10. So at -10, way over here, you would go down 1/10. So we could see that it's super close to the x-axis. As a matter of fact, going this way, we could safely say that it'll infinitely get close to the x-axis, but never actually touch the x-axis. So when you draw it, you could draw it like if it's actually touching, but we know that it doesn't actually touch. It just infinitely approaches going that way forever. Maybe I shouldn't have extended it all the way this way because we need a XY table, or we need that space for the XY table. Anyway, so what's happening over here? That's the question. So we said if we plug in 0, it's undefined. That means that there is no output for the input 0. So there's like a gap right here. In other words, there's an asymptote right here. So let's see what happens between the value of -1 and 0. So like, what if I were to plug in -half? Where would my graph be at? And let's show that. Let me plug in a -1/2. And think about that. You'd have a 1 over -half. Let me write that out. And that really means 1 divided by -half. So if you were to write that out horizontally, it would look like this. And of course, whenever you divide by a fraction, it's really multiplying by the reciprocal. So you really end up with 1 times -2 over 1, which is really just 1 times -2, which is -2. So if I do plug in, it got kind of messy right here. So got messy right here. So let's do this. Let me just scratch that out, and let me put the input of -1/2, because that's what we plugged in. And when we plugged in the -1/2, we got out a -2. So let's go to the coordinate -half, -2. -halfway on the x and -2 on the y. As you could see, it will continue this way, and it'll continue to infinitely approach the x value of 0, but never actually touching it, just infinitely approaching it. And that's the definition of an asymptote. So let's draw it like that. If you don't believe me, let's plug in one more value. Like, let's say I plugged in a -1/4. All right, so like, let's say I plug in a -1/4 into my x's. All right, so if I plug in a -1/4 right there, it'll be 1 divided by -1/4. Kind of look like this, 1 divided by, but -1/4 instead of -1/2. So it'd really be 1 times negative 4 over 1, which is really 1 times negative 4, which is really just negative 4. I hope you guys were able to follow along right there. When I plug in a negative 1/4, I do get out a negative 4. So negative 1/4, that's not even halfway. It's really close. It's half of the half, and then it'd be going down this way. So right here it'd be a negative 1/4. So as you could see, it is true that this continues to get closer and closer and closer to that x value of 0. So what we have here is two asymptotes. We have the x-axis, that's an asymptote, and we also have the y-axis, that's an asymptote. And this is what our graph looks like right here. So we should put arrows on it to be thorough, because it does continue in those directions forever. But as you can see, we've only plugged in negative input values. So what would happen if we plug in positive input values? Let me do that over here. Let me plug in some positive input values. Let me plug in the value of 1. And if I plug in the value of 1 right here, 1 over 1 is 1. Okay, so let's go to the coordinate 1, 1 and put a dot right there. How about the input of 2? What if I plug in a 2 right here? Positive 2 would be a 1/2. Okay. So where's the coordinate 2 and 1/2? It would be right there. And then continue. Let's plug in a 4. And when you plug in a 4 down here, it'll say 1/4 as an output. So you will end up with 4 1/4. 1, 2, 3, 4, and 1/4 of the way up. It's super close to the x-axis. So as you could see, this guy is going in this direction. You know what? Maybe I should do them, since this is one graph, even though they have two asymptotes. They should be the same color. So anyway, what happens between the 0 and the 1? On the x-axis, this is the x-axis. What happens between 0 and 1? So if I plugged in 1/2, where would my graph be? Plug in a 1/2 right there. It's really 1 divided by half, which is really something like this, 1 divided by half, which would really be 1 times 2. If you flip 1/2, it becomes 2. So 1 times 2 is 2. So if I did plug in a 1/2 for my x's, I will get a 2 for my y. And let's see where that takes us. 1/2 on the x, 2 on the y. And as you could see, this is our graph, and it will continue to go closer and closer and closer, infinitely getting closer to the y-axis, which is really the line x equals 0. So we do have two asymptotes. This is called, it's a form of a hyperbola, right? Vocab's really not too important right now. Right now I just want you to get an understanding of when you have a variable in the denominator, things at some point will mess up. Now what do I mean by mess up? You cannot plug in the number 0. And we're talking about x's here. Here's the x-axis. What happens at the value of 0 for x? Well, there's no graph. It's undefined. There is no y value for the x value of 0. There is no output for the input of 0. It would be undefined. And not only that, we do have two asymptotes. Not only is it the x value of 0, but it's also this asymptote over here, the y value of 0, which is also known as the x-axis. So let's take a look at this same exact graph. So here's the same exact function. Obviously, we don't want to graph the same thing. That'd be a waste of time. Let's change this. And what if I changed the denominator x to become the denominator x plus 1? Okay. So we have the function y equals 1 over x plus 1. So this is actually your homework for today from this video. All I want you to do is to think about, make an xy table, actually, it could just be one xy table, and plug in some values, see what it looks like. It's going to look like the original, the one we just did looks like this. That one was where we did not have a plus 1 down here. So what I want you to do is, on your own time, on your own paper at home, make an xy table for this. It's going to look like this, but something's going to change, all right? Something's going to change. And that's what I want you to write down. That's your homework. Just tell me what happens when you put a number down here. Okay, what happens when you put a number down here? A couple of sentences will do. I need some type of explanation. Obviously, it's not going to look exactly like this. It's going to look very similar to it, but I guess maybe I'm saying too much right here, but there will be a shift. All right, so check that out. Try to do that. And I also want you to look at the same function, but instead of, let's say, instead of having a plus 1 down here, let's put a plus 1 out here at the very end. All right, so we have the function y equals 1 over x. No plus 1 down here in the denominator, but plus 1 out here separate from the fraction itself. And then make an XY table, graph it, and see what it looks like. And of course, it's going to look like this, like the original one that we did, but there's going to be some type of shift on it, okay? So that's your homework, just to describe what kind of shifts happen when you do put a number down here with x in the denominator or a number out here by itself, okay? I mean, you could probably, once you get it, you could probably explain it like within 2 or 3 sentences. That's all there is for homework, all right? Cool.